Question 10, this is an equilibrium question. So I've got this dicarboxylic acid, I've got methanol, it looks as if I'm making a diester, two esters within the same molecule, and 2 moles of water. Write an expression for the equilibrium constant for this reaction. Use X and Y in your expression. So I'm replacing this this dioic acid, this ethane dioic acid, butane dioic acid rather, with X, and I'm replacing this diester with Y. So my equilibrium constant is 1 mole of Y multiplied by the concentration of H2O squared divided by concentration of X and divided by concentration of methanol squared. A mixture of 0.32 moles of the acid and 0.84 moles of the methanol were allowed to reach equilibrium. So you write the equation out and then you put a little table underneath. That's the way to set it out. So you write the equation out, X and methanol and Y and water, and it tells you then at the start how much of each you've got. So you write that in the first line. At the start I've got 0.32 moles of X and I've got 0.84 moles of the methanol. It doesn't tell me how much Y I've got and how much water I've got, so I'll have to assume that there aren't any in the mixture at the beginning. We haven't made any yet. And it tells me that I make 0.26 moles of Y. Well, if I make 0.26 moles of Y, when 1 mole of this is made, 2 moles of water are made. So if I make 0.26 moles of this, I must make double the amount of water. 0.26 times 2 is 0.52. So I've now got the amounts of these in the mixture. When I make 1 mole of this, 1 mole of this is used up. So if I make 0.026 moles of this, I use up 0.26 moles of this. I started with 0.32, I've got 0.32 minus 0.26, I've got 0.06 moles of this left over. When I make 1 mole of this, I use up 2 moles of this, so 0.26 times 2 is 0.52. I've used up 0.52 moles of this. I had 0.84 in the original mixture, subtract the 2, 0.32. Calculate Kc, so I've got to put these numbers in now. So I take Y, number of moles of Y, and divide by the volume, H2O squared, so 0.52 squared, divide by the volume, X is 0.06 in the mixture, divide by the volume, methanol is 0.32, it's got to be squared, divide by the volume. But you'll see I've not been given the volume. But it doesn't matter because there's 2 volumes on the top and 2 volumes on the bottom. So when I get equal numbers of moles on the left hand side, 1 and 2 is 3 and 1 and 2 is 3, the numbers, the volumes cancel each other out. So I don't actually need the volumes at all. So I can just use 0.26 multiplied by 0.52 squared divided by 0.06 and divided by 0.32 squared, and it comes out as 11.44. My other values are two significant figures like 15, 0.84, 0.32, so I'm going to round this down to 11. There are no units because there's 3 concentrations on the top and 3 concentrations on the bottom, and that's again why I can get away without converting moles into concentrations. In other words, why I don't need volumes. Predict the effect of Kc if the reaction is carried out at a lower temperature. Now, changing the temperature does affect the equilibrium constant. So it's an exothermic reaction. So if I lower the temperature by Le Chatelier's principle, it'll try and increase the temperature. It will move the equation to the right-hand side, shift the position of equilibrium to the right-hand side, because this is exothermic in the forward direction. So it'll shift the equilibrium to the right-hand side to give out heat in exothermic reaction and try and oppose this change of lowering the temperature. And if I shift it to the right-hand side, then I make more of the products. And so if I make more of the products, my equilibrium constant is going to increase because these numbers on the top will increase, the numbers on the bottom will decrease. So my equilibrium constant increases.